Problem number 4. Mandy is buying plants and soil for a flower bed for her mom. The soil costs $5 per bag and the plants cost $12 each. She wants to buy at least 6 plants and can spend no more than $100. Write a system of linear inequalities to model the situation and then solve. Let's identify the variables first. Let x be equal to plants, number of plants, and let y be equal to bag of soils. So we're good with variables. Now we need some number equation and cost equation. So soils cost $5, so 5y, and then plants cost $12 each, so 12x. And she wants to buy at least 6 plants. So x is at least 6 means greater than or equal to 6. Can be above 6, can be equal to 6, cannot be less than 6. And she can spend no more than $100. That means she can maximum spend $100. And $100 is inclusive. Now let's graph it. Let's let's label and then scale. Our x-axis is plants and our y-axis is soil. X is greater than or equal to 6. Let's solve for y and then decide the scaling. So 12x plus 5y is less than or equal to 100. Subtract 12x on both sides and then divide everything by 5. So we have y is less than or equal to negative 12 over 5 plus 20, not 220. Okay, so we can scale 2, 4, 6, 8, 10. Yeah, we can scale 2 by 2. Okay, our y-axis can be 2 by 2, 0, 2, 4, 6, 8, 10, 12, 15, 16, 18, 20, 22. And our x-axis can be either 2 by 2 or 1 by 1. Let's go 2 by 2. Okay, our one equation is x is greater than or equal to 6. It's a vertical line on the x-axis. So go to 6 and make a vertical line. Because x equals to some number is a vertical line. Now we're going to shade left or right hand side of this line. We're going to shade right hand side because it says greater. And it's going to be solid line because inclusive. Now let's shade right hand side. Now the second equation has y-intercept 20. So we go to 20 on the y-axis. And our slope is 12 down, 5 right. If I go 12 down on 20, I come to 8 and then 5 right. 5 right is here. Again, 12 down is negative number, negative 4, and then if I go 5 right from here, it's going to be 10. So it's going to be, so our y-intercept is 20, our x-intercept is a number between 8 and 10. I can roughly make this. Anyway, we have to connect these two dots and straight line goes x-axis at this point. Now it's going to be a solid line because it says less than. And we're going to shade below this line because it says less than. So our double shaded region is where? This is our double shaded region, this little triangle here. So this is our feasible region. So that solves the both strain constraints. So any point on this line or in the region is the solution. For example, 7 comma 2 or 7 comma 4. Problem number 5. Josh is going to the store to buy candy. Bags of candy corn cost $3 and bags of chocolate cost $5. He needs to buy at least 20 bags of candy and cannot spend more than $60. Write a system of linear inequalities to model the situation and then solve. First, we need to identify. Let x be equal to bags of corn, candy corn. And let y be equal to chocolate, bags of chocolate. So we're good with variables. Now we need number equation and cost or value equation. We know that candy corn costs $3, so 3x, and bag of chocolate costs $5, so 5y, and he cannot spend more than $60. So maximum money he can spend is $60 means less than or equal to 60. And we know that he needs to buy at least 20 bags of candy. So candy is x variable and he wants to buy at least, so greater than or equal to 20 bags. Now using these constraints, we can graph the equation. Now let's make the x-axis candy corn and y-axis chocolate. X is greater than 20. Let's solve for y here and then decide the scaling. 3x plus 5y is less than or equal to 60. Subtract 3x on both sides. So negative 3x plus 60. And divide everything by 5. So y is less than or equal to negative 3/5 plus 60 divided by 5 is 12. So we can go 2 by 2. 0, 2, 4, 6, 8, 10, 12. And on the right, we can still go 2 by 2. 10, 12, 14, 16, 18, 20, 22, 24. Now one of the inequalities x is greater than 20. So we need a vertical line on 20. Because x is greater than 20 has to be on the x-axis. And we're going to shade right side of this line because it says greater. And it's a solid line because it's inclusive. So anything on the right side of this line satisfies the inequality x is greater than or equal to 80. Now, the second inequality is negative 3/5 x plus 12. So 12 is the y-intercept. And slope is negative 3/5, which means 3 down, 5 right. 3 down from 12 is 9. 9 is here. Be careful with the scaling. And 5 right. 5 right is 5. And then again, 3 down. From 9 to 3 down is 6. And 5 right is 10. 3 down is 3, and 5 right is 15. 3 down is 0, and then 5 right is uh, this was 10, 15, then 20 here. So our line is connecting 12 to 20. And here we're going to shade below this line. Okay, so where is the solution set? Do we have any double shaded region? There is no double shaded region. However, we have one single intersection here. That is the only solution, which is 20, comma 0. Is the only solution here because there is one single intersection. And we can't go to negative numbers here because you can't buy negative number of the bags. So 20 bags of candy corn and 0 chocolate is the only solution. If they want to make if they cannot spend more than $60.